Assalamualaikum. We are from Group 1 and we will be presenting on basic applications of pneumatic actuators. Industrial automation systems frequently use pneumatic actuators because of their simplicity, affordability, and quick response time. They are crucial for controlling robotic arms, lifting mechanisms, and valves because they use compressed air to produce linear or rotary motion. Single-acting and double-acting pneumatic actuators are two popular varieties.
Single-acting pneumatic actuators. Working principle. A single-acting pneumatic actuators use air to move a piston in one direction and a spring pushes back when the air is released. Application. Single-acting pneumatic actuators are used to open and close a valve, move parts, climb objects, and return to safe position during the power or air failure. Advantage. It uses less air, making it energy efficient. Simple design with fewer parts, easy to maintain. Third, spring returns provide a fail-safe operation. Disadvantage is provide less force compared to the double-acting actuators. It has limited stroke length due to the spring's constraints. Lastly, springs can wear out of low strength over time. You can see in the picture there are single acting component, and when we see diagram in the fluid sim, we can see single acting pneumatic fluid in program. Thank you.
Next, double-acting pneumatic actuators. It uses compressed air for both the extension and retraction strokes. Air pressure is applied to either side of the piston depending on the desired motion. It is commonly used where force is required in both directions, such as in robotics, valve extractions, and material handling system. Its advantages are it is more powerful and efficient in both directions. It has no springs, so it provides consistent performance. It is better for precise control. Its disadvantages are it is more complex and costly than single-acting, and it requires more air and through control valve. In the figure on the right, the first figure is double-acting component developed by Hirken, and the second figure is a double-acting symbol in fluid sim software.
Assalamualaikum, my name is Muhammad Azimuddin. Today, we are going to explain about how actuators works in fluid sims. Okay, first I'm going to use a single acting actuators and double acting actuators. And for the valve, I'm going to use a three-way valve for the single actings and five-way valve for double acting. And to control the speed for the actuators, I'm going to use a one-way flow control and for the both actuators. And lastly, I'm going to compress air for the both actuators to see how the actuators work. For the output, I'm going to use a silencer because if I didn't use a silencer, the sound may be too loud for us. Okay, now we can see the compressor show the valve move um in the actuators. Okay, I'm pass my to another teammate. Thank you.
I will start by explaining for the single acting actuators. At rest, when there's no actuations, the 3-2 directional control valve is not pressed. Therefore, the air supply from the compressed air is blocked. The cylinder is retracted by the internal spring. So, when the button is pressed, the 3-2 directional control valve that connects the air supply to the single acting actuators and which makes the valves to shift. Compressed air flows through the cylinder pistons, which makes the cylinder to extend. When the button is released, the valve returns to its normal position, which makes the spring to return to its initial position. And port 2, which is the single acting actuators, is now connected to the exhaust. Air from the cylinder is released and the spring retracts to the cylinder.
I will be expanding on the double acting cylinder control. In initial conditions, the directional valve is in its default position. The compressed air is sent to the right side of the cylinder and a signal from a sensor of valve will shift the 5-2 valve, which is the directional control valve. Now, compressed air will flow to the head side of the cylinder. Cylinder extends and full control valve will control its speed. At full expansion, a sensor or the limit valve will detect the full extension and send a signal to reverse the directional control valve. The air will be redirected to the root side of the cylinder, and the cylinder will retract and opposite side is exhausted. Next, we are going to compare between single and double acting pneumatic actuators. For the first feature, it's motion type. For single acting actuators, one direction in air retained by spring. For double acting, it's both directions, air in both sides. Second feature is air consumption. For single acting actuators, it's lower, uses air in one direction, and for double, it's higher, air used in both strokes. For force output features, lower for limited by string force, and for double acting actuators is higher, force applied both ways. Lastly is speed. For single acting actuators, slower on return stroke, spring, and for double acting actuators, it's more consistent speed in both directions. In conclusion, both single acting and double acting pneumatic actuators play vital roles in industrial automation. The selection between the two depends on the application's specific requirements, such as directions of force, energy efficiency, and safety consideration. That is all from us. Thank you.